Today we're going to discuss Mini Project 3 where we use slime. In part 1 of the experiment, we're going to answer the questions that were asked when we made slime. In part 2, we're going to answer the questions to our bouncy ball, and then we're going to compare the two. The ingredients for our bouncy ball, or for our slime, were water, borax, and glue. And the portions that we used were 1 teaspoon of borax and 1/4 cup of water, and 1/2 cup of glue and 1/2 cup of water, and then we mixed the two solutions, which made our slime. First question asks us to hold the slime with both hands and pull it apart very quickly. How does it deform? And here's us performing that.
Ready?
Yeah, it's on.
So it's just gonna...
When the slime is pulled apart quickly, it snaps or breaks suddenly rather than stretching smoothly. This is because the polymer chains in the slime do not have time to uncoil and slide past one another, so the material behaves more like a brittle solid under fast stress.
Ready?
Question 2 told us to hold the slime with both hands and pull it apart slowly. How does it deform? And here's us performing that.
I'll do it slowly.
When pulled apart slowly, the slime stretches smoothly and continuously, forming long, thin strands. This polymer chain has time to rearrange and slide past one another, so it behaves more like a rubbery material. This demonstrates viscoelastic behavior. Question 3. Hold the slime with one hand and let gravity stretch it, or we could roll it into a ball and let it sit on a flat surface. What happens, and what is this an example of? We chose to roll it into a ball and leave it on a flat surface. And here's a time lapse of the slime. As you saw, when the slime was left to stretch under the force of gravity, the slime slowly spread out over the surface. It does not hold its shape like a solid would, and this is an example of creep, which is a slow and continuous deformation under a constant force, which in this case was gravity, which is a property of viscoelastic materials. Question 4 asked us to pull the slime apart and hold it at a fixed distance. The force required to keep it stretched should decrease. What is this an example of? And here's us performing that. As you saw, it did take more force to keep it stretched before the phenomenon happened, because the phenomenon was called stress relaxation. Initially, the slime resisted being stretched, but over time, the force needed to hold it in place decreased as the polymer stretched. And a side note is that the drooping that started to occur because of the force of gravity is also an example of creep. Now, part 2, making the bouncy ball. The ingredients we used were the same, water, borax, and glue, but the portions were different. We used 1 teaspoon of borax and 1/2 cup of water, and 1 teaspoon of glue that we put directly into the solution. And here's us bouncing the ball. In the video, it bounced roughly 1/2 foot, 1.5 feet. Question 2. How did the change in recipe or procedure help the bouncy ball have a more thicker and help to become a more bouncy ball recipe? To get a more firmer, bouncier texture, we used more borax in relation to the amount of glue we used. We had 1 teaspoon in both experiments, but only 1 teaspoon of glue in the second experiment versus in the first experiment we had 1/2 a cup of glue. We also mixed the glue directly into the borax solution instead of diluting it with the water. And then as soon as it was done, we put the ball out and we rolled it with our hands instead of letting the slime out to dry. This increased the cross-linking density in the polymer network, creating a more solid, elastic material. In question 3, how did this change in recipe change the polymer structure? The increase in borax concentration and direct glue contact caused more cross-links between polymer chains, turning the mixture from a loosely connected gel, which was slime, into a tighter, elastic network. And the resulting structure is less flexible but more resilient, allowing it to hold its shape and bounce. In question 4, roll your original slime into a ball and put it next to your new bouncy ball. How do the shapes change over time? And here's that time lapse. Okay. As you saw, the slime ball slowly spread out over time, while the bouncy ball retained its shape with little to no deformation. And then question 5 asks us, which of the two batches has a higher Deborah number, and how can you tell? And I believe that the bouncy ball has a higher Deborah number. Because as you see, the Deborah number compares to the material's relaxation time as we watch it. And since the bouncy ball keeps its shape and rebounds quickly, it reacts to a short time scale like an elastic material, while the slime has a slow flow over time and has a lower Deborah number. In conclusion, this project demonstrated how changing the ratio of glue, water, and borax affects the property of a polymer. By making slime in a bouncy ball, we observe the transition from a soft, flowy, viscoelastic material to a firmer, elastic one. Since slime shows behavior like creep and stress relaxation, while the bouncy ball held its shape and bounced, indicating stronger cross-linking and a higher Deborah number. And then overall, we showed how polymer structure impacts material behavior under different conditions. Thank you and have a good day.